In this video, I'm going to show you how to use the simulation app for this week's activity. This simulates a two-sample t-test. So up here we have the mean of population 1, which is unknown, and we have the mean of population 2, which is unknown. And the two populations can be whatever you want them to be. They're just two imaginary populations. So they could be two cities, they could be two colleges. And what this question mark represents is the mean age of population 1, and this question mark represents the mean age of population 2, and the two numbers are known. We don't know what they equal. But the null hypothesis says that they're the same number, that they're equal, and the alternative hypothesis says that they are not the same number, that they are unequal. That's because in a two-sample t-test, the null hypothesis is always the possibility that the two population means are equal, and there's no difference. And the alternative hypothesis is always a possibility that the population means are unequal and that there is a difference between them. And what this allows you to do is actually randomly sample from these two imaginary populations and collect data from your samples. So first you have to click on Take Samples. And when you do, it randomly selects 5 people from population 1 and 5 people from population 2. And records their ages. So here we have the ages of a total of 10 people. Then what you do is you press calculate, and you'll get the mean of these 5 people in sample 1, the mean of these 5 people in sample 2, the standard deviations of the two samples, the total sample size of 10, and the t-score, the t-statistic. And this t-statistic is what you calculated in last week's assignment. Now what you do is you set your alpha to 0.05, which is the same thing as a 95% confidence level. Alpha and confidence go along with each other. Then what you do is you look at the t-score and you decide which of these 3 areas it falls in. Negative rejection region, non-rejection region, or positive rejection region, just like you did in last week's topic. So here, negative 9.92, that's to the left of this negative critical value. So it's in the negative rejection region out here. So I'll choose that. I'll select that, and it's correct. And it's marking my t-score out there. And if I had selected the wrong one, it would have just said try again. Now what I do is I have to make a decision. So if my t-score is in one of the rejection regions, one or the other, I reject H0, which means reject the null hypothesis. This just means I'm rejecting the possibility that the population means are equal. I click that, and when I do that, the simulation actually tells me what the two population means are. They were 35 and 45. And if you look at it, I think that makes sense because you can see that this sample mean is pretty close to 35, and this sample mean is pretty close to 45. So, because remember that this sample mean is an estimate of this, and this sample mean is an estimate of this. And if it's a random sample, it's likely to be a fairly good estimate, especially if it's a large sample size. So now what you do is you have to decide if you made the correct decision. So you rejected the null hypothesis, which means, well, I rejected the null hypothesis, which means I rejected the possibility that the population means are equal. And now I can see the population means, and I can see that they actually are different, which means the null hypothesis is false. That would make it a can do. Then after, restart the simulation. And now I'll be sampling from 2 completely different populations. Once again, this is still the mean age of population 1, and this is still the mean age of population 2, but the two population means aren't necessarily the same numbers that they were before. They might not be 35 and 45 this time. And what I do now is, once again, I leave these as question marks, and I click Take Samples, and I'll get another 2 samples of 5. So now, Now I have two new samples of 5, and now what I do is I just do the same thing over again, calculate, and now I have my t-score. I do alpha of 0.05, and now my t-score is still in the negative rejection region because negative 2.91 is out here. So once again, reject the null hypothesis, and then it's a, let's see, and now it actually tells me the population means again, and once again they are unequal. So I made my correct decision. I rejected the null hypothesis of equal population means, and it turned out to be the right decision. And when I press reset, it'll allow me to do a third trial of this simulation. And each time I click reset, it gives me an update. It gives me an update over here. And it keeps a record. So let me try that. Yeah, so right here I have a correct decision for, well, the null hypothesis, each one was true. Each one is unequal population means, and I correctly decided that the population means weren't equal, so I got a mark right here. And these other 3 are still all 0. So what I'd like for you to do on your assignment is repeat this 20 times. So you're going to be doing 20 different 2-sample t-tests, and each time you'll either reject or retain the null hypothesis right here, and you'll either have a correct decision or one of these decisions, or you'll either have a correct decision or one of these outcomes. And then, yeah, so remember, each time you click reset, you're doing a new 2-sample t-test, a new simulation, and I want you to repeat it 20 times. After you're finished with that, what I'd like for you to do is do 20 more simulations, but this time, each time you do it, have a total sample size of 100, and I'll show you how to do that. What you click on is Build Progressive Sample, and then keep clicking on Take Samples until your sample size builds up to 100, and it'll go up 10 at a time. So now we have a total of 100 people, 50 over here and 50 over here, but it's only showing the most recent 10 people. And I can click on, once again, Calculate, and now I have a t-score of 15.99. So when you have a larger sample size, that actually makes the t-score come out larger. Here, it's positive rejection region because it's above the critical value. Oh, I forgot to click my alpha because that tells me what the critical value is. So remember, each time you do this, click alpha 0.05, and that'll give you the critical values. I'm in this rejection region, so I reject the null hypothesis. And let's see, the population means are unequal, so I made the correct decision again. And now what I do is I just click reset, and this will be finished, and I'll start a new trial, and that'll be my next 2-sample t-test, and then I'll just repeat that 20 times. And when you're doing this, make sure that to leave these as question marks when you're first doing the sampling, because in a real life 2-sample t-test, the population means are unknown, and you're trying to use your data to make the best possible guess about whether the population means are equal or unequal. So leave them as question marks because they should be unknown. But it just happens to be that in this simulation, it provides you the population means after you make your decision. That's just for learning purposes. It's just meant to help you get the concepts down. But that wouldn't happen in real life. In real life, they would still be unknown, and you would just hope you made the right decision. And also, I needed to mention that, remember, if it's in this left area, reject the null hypothesis. If it's in the middle, retain the null hypothesis. If it's in that right area, reject the null hypothesis. Because remember, the left and right are rejection regions. So if it's in the left area out here, I click reject H0. If it's in the middle, do not reject H0. If it's in the right reject H0. If you need a little bit more of a detailed review, go back and review the two-sample t-test topic with the critical value method. Also, I needed to mention that if you reject the null hypothesis right here, you're deciding that the population means are unequal. And if that turns out to be true, like it was here, it's a correct decision. But what if you rejected the null hypothesis and it turned out that the population means were actually equal, the same number, like 40 and 40? Well, if you did that, you're rejecting the null hypothesis, and the null hypothesis actually turned out to be true after all. In that case, that would be called a type 1 error. If you reject the null hypothesis and then you end up being wrong, it's a type 1 error. Yeah. And what if you click do not reject H0, which means you're deciding to stay with the null hypothesis, to hold on to it, and assume that the population means are equal? Well, if it turns out that they are actually equal, you've made a correct decision. But if it turns out that they're different numbers, then you've actually made a wrong decision about the populations. It would be a type 2 error. So if you reject the null hypothesis and you're wrong, type 1. If you do not reject and you're wrong, type 2 error. So if you do this and you're wrong, type 1 error. If you do this and you're wrong, type 2 error. And as you go along, it'll keep track of your type 1 and type 2 errors. And yeah, so that's really it for this, for me to walk through the simulation. If you need any more explanation about type 1 or type 2 errors in more detail, just either review the two-sample t-test topic, or you can come and talk to me this week on Thursday.